Should I send the handout on part 5, section 2? Okay, what we do in chapter 5, we investigate or we cover more shortcut methods. Shortcut methods. Okay, circuit analysis methods so far, circuit analysis, general circuit analysis methods. So far, we have KVL, KCL. This is considered a general method. The problem with general method is the fact that you have many questions, many unknown. So that's why we try to avoid general method. Then we have voltage division. If you remember, we covered before exam 1, voltage division and current division. Okay, for series circuit and for parallel circuit. Then we talked about shortcuts, nodal, mesh. So these are general, these are the circuit methods that we can apply to any circuit in order to analyze and in order to find the unknowns. There are 2 additional circuit analysis methods that we cover in chapter 5. So in chapter 5, section 1, we cover 2 additional methods. One of them is called superposition, and the other one is called source transformation. So with these 2 methods, we cover almost all circuit analysis methods, shortcut methods available. Superposition and source transformation, especially source transformation, is very useful technique, you will see when we go through examples. And section 2 of chapter 5, we talk about circuit modeling, circuit model, or reduced model. So we show you, for example, if you have a circuit in the box, like with many elements, like many resistors, you can actually take the whole circuit and substitute only by 2 elements. Equivalent model. That's also very useful concept in circuit analysis. So today we start with superposition. I sent you a handout for superposition, source transformation. Very 2 simple method, kind of short handout. I'll go through some examples in class and I'm going to assign problems for you to practice. And then after that, we do Thevenin, Norton, or circuit modeling. I go through several examples in class. I think today I have time to involve class in answering questions. As I said, most of you, many, they just tune in and maybe they leave the room, they don't listen, but I want to involve you in applying superposition and source transformation from the beginning, so that way you probably get a better feeling, better understanding of these 2 techniques rather than me just writing formulas on the board and doing problem on my own. So I try to involve you for these 2 techniques because they are very simple, straightforward techniques, and you can find many applications for them. So let's do that. Do you have any question? Again, last call. Any question before I start? Okay, so let's just start with superposition. Okay, superposition has application, important application. When you have AC, DC combination. We haven't covered AC yet, but later when we cover AC, there are some cases that you have to use superposition. Remember, shortcut, you don't have to. You don't have to use nodal. You don't have to use mesh. It's better to use nodal. It's easier to use nodal. It's easier to use mesh, but you don't have to. Like if they give you a circuit and ask you to find a voltage, you can use any method. That's the point. You can use any method. But maybe if you apply nodal, it's easier. Maybe if you apply mesh, it's easier. So it's recommended to use nodal, mesh, voltage division, current division. That's why you are learning these methods, because it makes it easier. It makes the process easier. Some of you may say, okay, there are many computer programs available, like PSPice, for example. I can use computer to solve circuit for me. Remember, you can use computer problem when circuit all parameters are given. But especially in electrical engineering, you're dealing with design problems. In design problems, some parameters are not given. Then you have to do setup on your own. You have to set up equations on your own. You cannot use computer. So that's why you need to know these methods. Okay, for superposition, you eventually appreciate this technique later. When you have multiple sources with different shapes, for example, one voltage source is DC, one voltage source is AC, one voltage source is ramp function. When you have sources with different shapes, then superposition probably is the easiest method to apply. And especially later when you have a combination of AC, DC, which is very normal to have a combination of AC source and a DC source. They're two different signals. When you have this combination, then in some cases you have to use superposition. So let's consider, so that's why we are covering superposition. Nodal and mesh may be easier to apply nodal mesh, but you need to know superposition. Some people, because it's simple and straightforward, and also for future application, you need to know the superposition in order to handle AC-DC combination. Okay, superposition is based on the following concept. Okay, superposition is based on the following. You keep, okay, in case of superposition, you have multiple, two or more independent sources. So you don't apply superposition when you have a single source. And it has to be independent sources, multiple independent sources. So you have a circuit with multiple voltage current source combination. That time, superposition, you can apply superposition. Okay, superposition is based on very important general idea in math. So in mathematics, in math, if you have a linear equation, well, let's say we have a linear system. Okay, let's say you have a linear differential equation, okay? So let's say we have dy dt plus y equal to x, okay? If you apply x1, you solve the differential equation, you find y1. If you apply x2, you solve the differential equation, you find y2. If you apply ax equal to ax1 plus bx2, you don't have to go back and solve differential equation. Actually, you can take the results from individual input and the output or the solution of differential equation is equal to ay1 plus by2. This concept is linearity condition that they cover in mathematics. In mathematics, this is the way they explain. If you have a linear differential equation, ordinary differential equation, if you apply one input and get the output, another input, find the output. If you apply the summation of inputs, you can extend it to 3, 4. If you have 10 inputs, find response to each one of them individually, put it aside, and at the end, add them up. And if you put any coefficient, they're multiplied by the same coefficient. That's very, very useful and very famous concept for linear systems. I think in mathematics, if I remember correctly, many math books, when they start differential equation chapter, they always start with this linearity concept, that for ordinary differential equation, which represents a linear system, if they give you a linear combination of many inputs, you don't have to apply all of them at once. You can apply one at a time, per input, find a solution, and at the end, add them up. So superposition is based on this concept. When it comes to circuit, you have multiple independent sources. So in this case, you have multiple, two or more, independent sources. Keep one at a time. Find the output. Keep one at a time. Find the output. At the end, add outputs. It's a very simple concept. That's why I said it's a very short handout. I have nothing else to say. If you have multiple independent sources, you cannot kill dependent source, only independent sources. Dependent source may be part of the circuit, but you have to keep your independent source at all times. So keep only one independent source at a time, find the output and add them in. This is basically the meaning of superposition. Okay, at this point, I'm going to start doing problem with class because there is nothing new. I'm doing the same circuit analysis problem. Actually, it's a material from chapter 2, like basic circuit, Ohm's law, whatever. But I'm going to apply the concept of superposition. So I'm going to clear example. This example is from handout. It's in the handout. Okay. Let's assume the following circuit, circuit is given, 20 ohm, 30 ohm, and then I have current source, 2 amp, okay, plus or minus V. Question is find V. Okay, remember for nodal mesh, the first thing was forget about the question. In this case, you must consider question from the beginning. You must consider the question from the beginning, from the starting point. Okay. I'm going to keep one source at a time, and in order to do that, I do it with your participation. So let me go to Aguilar.
Yeah.
Okay, for this circuit, how many? Let's do it one step at a time. How many independent sources can you identify for this circuit? How many independent sources?
2.
2. Oh, 15 volts and 2 amps, right?
Yes.
Okay, let's go to Alejandro. So first check the number of independent sources, identify them. Alejandro? Santiago? Alejandro? By the way, some of you have started, not all, to get absences, number of absences. Remember, after 3, I start to deduct point, and if it's 5 or more, I mean more than 5, you can take the exam. I just want to remind everybody, just to make sure that you know that I very closely follow the guideline, the course guideline, especially for this course because it's a basic course and it's very important. And you learn most of circuit analysis by attending and participating. Amador, Henry Amador. Amador. Argandona. Anybody?
Yes, I'm here.
Okay. So we have 2 independent sources. Superposition is based on keeping one source at a time. Okay. So I have two independent sources, so I have two cases. Case one, I'll keep 15 volts, kill 2 amp, because you have two sources. Just keep one of them. Okay, so I'm going to draw plus or minus 15 volt, 10 ohm, 20 ohm, 30 ohm. Okay, I'm going to kill 2 amp. What should I substitute? I don't know. I'm killing a current source. When you say I kill current source, killing current source means current source is not generating current. So what do I place here?
I'm not sure.
Why? We are way into circuit analysis.
I think I'm
Class.
just confused on what you're trying to ask me.
I'm turning off the current source.
Mhm.
Current source is not generating current. It generates zero current. So in my circuit, how do I show that? I did ask question in exam. Exam 1. Did you see the solution in exam 1? I asked you to kill sources. Didn't I mention how to kill voltage source, how to kill a current source?
Don't you just have nothing there?
Okay, so what should I put here? When you say nothing, what do you mean? I have to show the circuit.
Just like a line to close it off?
This is a short circuit. There's a current here.
Mm-hmm.
Let's go to Beltran. Jesse Beltran.
Yeah, I'm here.
If I kill the current source, what should I do here?
Do you add a resistor?
There is no resistor. There is a current source, and I'm turning off the current source. The current is not generated. The current is zero. What shows zero current? What should I put? Okay, they give you this circuit. They ask you to redraw the circuit and kill 2 amp. Okay, this is redraw, kill 2 amp. What do you place here? What should I do here? The terminal that the current source is. Did you study the solution for exam 1? One of the question. If the current is zero, what should I place here?
Don't you create a short circuit?
Why?
Short circuit, there is a current.
Open circuit?
Open circuit.
Open circuit. So when the previous student said nothing, you have to clarify, it's open circuit. So when you kill the current, it's open circuit. Okay. If this is open, what's the current passing through 30 ohm? If this is open, what current is passing through 30 ohm?
0.
0. Okay, let's go to Bernal.
I'm here.
Okay, for superposition, you keep only one source. You kill voltage source. When you kill is a short circuit, open current source is open circuit. Then you put the quantity in question back only for this case. Okay, based on your circuit analysis, basic circuit analysis knowledge back to chapter 2. What is V1?
Wouldn't it be 15 minus V1 over 10? Oh no. That would be 15.
Castaneda, what's V1? This is beginning of chapter 2 material, not even advanced learning. Abdul Castaneda,
V1, yeah.
what is V1? This is a circuit. They cannot give you a circuit easier than this one. If you're any student, if you take FE exam, this is a type of question you get in FE exam.
It's amp times resistance. It's on
Give me the
charge.
formula. Give me numbers. All the numbers are given here. Don't describe, just give me the number. Ivan Castro.
Hey, what's going on? It'd be I times 10 ohms.
Give me numbers. Everything is given numerically here. Give me numbers.
No, there's no current.
There's no current here.
Yeah, I know. I mean, there is a current, but I don't know the.
You don't know how to find the current in the circuit.
I mean, I do, but
Okay, what's the current?
It'll take me a while. I mean, you're kind of like.
Why it takes a no? Wait.
No.
This
wait,
wait.
Hold on.
This is a circuit. This is one circuit.
Wait. Can you stop making me feel dumb when you ask me a
It's
question?
not feeling dumb. You are not. I mean, I'm just.
Yes, you are, dude. Like.
No, I'm not. Don't talk to me like that. Don't talk to me. I'm not
talking
rude.
to me like that. Like
I'm not rude. I'm just saying that this is a single circuit. There is no current going on this side. There is no current going on this side. There is a single loop here.
I know that. Yeah, I know that. I mean, I could sum the voltages if you want, but it doesn't. I'm not as fast as you when you do this. Like I'm not as fast. I'm not as versed as you are in doing this.
It's not a fast. It's a single loop. I started circuit analysis course with this one, single loop circuit. What fast? I mean, how many times should I cover basics of circuit analysis? I mean, this is not easy teaching this class. That's why nobody wants to teach this class. Because the problem here is the students, they don't pay attention to circuit analysis. You're talking to me, I'm responsible. You know how many times I am criticized by my colleague? How many times? Because the students coming from this class don't know anything, they don't know the basic, and they blame it on me. This is the basics. There is no current going on this side. This is a simple circuit, 15 divided by 10 plus 20. What's so difficult about the current? It's a series circuit. How fast? This is fast. If they give you the circuit, 15 volt, 2 resistors in series because there is no current on this side. It's 15 divided by 20.
Yeah.
Other than that, we covered voltage division. You have a series circuit, V1 is equal to 10 ohm divided by 10 plus 20 times 50.
Yeah, I had to do the math. Like I figured it out. I'm just saying, like it takes me a little while.
Let's at this point, if you have a series circuit, we have only less than a month, almost a month, before the end of the semester. And I'm still in chapter 5, where you're taking this class at any school. They're already covering AC. I'm way behind. I'm going super slow. I'm involving. What you prefer is faculty, either taping something, putting available. I'm the one that trying to involve the students, just like face-to-face. Face-to-face, let me explain something, because you guys judging me, some of you, very unfairly. When it's face-to-face, I do see students. So I can tell if the students are paying attention. And I don't move away from topic because I see their faces. I can tell. Here, I don't see anybody. I don't know if you're listening to my lecture or not. In a given day, ask all my colleagues, when the class is larger than 20, at any time, in any class, if I stop the lecture and go around and ask a student, what was today's topic? Do you know, we have a statistic. I do have a statistic. Over 60% of a student, they don't even know what's the topic because they don't listen. They are checking their cell phones, they're checking iPhone, they're going away, they are working at the same time, they're taking care of other businesses. I do hear background noise. They are listening to music, they are watching TV, they are watching, talking to people. This is the only, this is not even a way to control. I cannot let a student leave this class when they still have problem with a single loop after almost 2 months of circuit analysis, teaching circuit analysis course, after teaching nodal and mesh. So don't judge me. When you say, I'm making you nervous, no, I'm not telling anybody is dumb or anything. I'm just saying at this point, I'm taking this class, I'm putting energy, providing material homework. When you're a student, you have responsibility, not you. I'm talking about general. and your responsibility, and I don't care. If you can go and say she has a temper problem, she is intimidating, whatever, but I'm trying to do my job. And I do the same thing because student, this is the course for electrical engineering. And I do hear from my colleague, I'm repeating 100 times, from my colleague just last week, 2 of my colleagues that they're teaching electronics, they came to me and said, what's going on with your circuit class? Students don't even know what is dependent source. What is my answer to them? And this is the class, I mean, online, I mean, it's not easy. Try, go and teach math to people online. So don't judge faculty, don't.
No
We
one is
have-
judging
we
you,
are
Professor.
I'm at the dark and I don't know anybody, I don't see anybody, in my class, I can control the situation. There is no way I allow a student to use iPhone in my classes. When I'm lecturing, no computer, they cannot leave the room, so that way I control. In my classes, when I have face-to-face lecture, I don't even ask questions from my class. I don't even involve class. Because I know for a fact that they are at least listening. With online, I don't have that available. I don't. And you tell me that this is a circuit, the current goes here 0. It's a single loop circuit. And somebody says, I cannot measure the current. The other person says, this is 15 volt across V1. Why? I mean, this is a loop. Another person says, there is a current going on here. At this point, as soon as if I ask you what's the current, at least I should hear, okay, voltage divided by summation of 2 resistors, or voltage division law. Okay, let's forget about, if that's the way you want it. Okay, no, wait. No, let me finish one thing. No, let me finish. No,
Can I
I
make
don't
a
want to
point?
take my
Dude, you
time.
don't need to
I
talk to your
don't,
students like that. Stop.
no. I
Stop.
just, let me say
There's
something.
absolutely no circumstance where you need to talk to someone like that.
No, I again, as I said, that's the way, that's my style. You can do whatever. You have a choice. They are offering circuit analysis course next semester.
Yeah, Professor.
fine.
We
But
just
let
want to
me
like,
tell you one thing. No. I don't want to take my time. Okay, I'll go back to whatever you want. From now
Yeah.
on, no class
Just-
participation. No, I'm not going to do any class participation. I just take class roll and that's it. So please turn off your mic. Just listen to my lecture and I'll do it all the way to the end. And if you have any problem, do whatever. Give me the worst evaluation, whatever you want to do. I'm doing my job. And I'm very satisfied with the way doing my job because this is the only way. And I have obligation and I'm just following my obligation. And if you're not happy, you're not satisfied, there are other much softer professors, they're teaching circuit analysis next semester. If you want, you can easily drop. Even if 2 students left in this class, I'm happy to continue with 2. If you're not happy, just drop and take it. If you're mechanical engineering, they also offer in mechanical engineering with mechanical engineering professor, or they offer it with another professor. So please mute your mic. If you have any complaint, go and complain to other people. I just want to finish my job. I'm a little bit behind. And let me finish. No class involvement from now on. Feel comfortable. So, and then wait, no, I don't want to hear anything. Please, if you want, send me an email and do whatever accusation you want. You can go ahead and do it, no problem. But the problem here is, I just want to do my job. I already wasted my time. So let me just finish this example. No class participation for this class. I just come, lecture, finish. You can ask questions. Please remember, anytime you can still open your mic and just ask questions. That's it. No class participation. You can just log in, leave the room, do whatever you want to do. I may even not even take class, roll calling. I may even stop doing roll calling. If you want to come to class, come. Don't want to come to class, no problem. Don't come to class. Let me just finish my lecture. So let's go back to this example. Here, the current is equal to 0. This is unbelievable. Instead of appreciating it, I'm putting so much time now. I have to be blamed because I'm talking down. I don't even know. I don't even see people here. I'm just going around and trying to force. I'm getting passionate. Yes, I'm getting passionate because I love to somehow getting students to get involved. Maybe sometimes I raise my talk louder just because I want to make my point across because I'm getting frustrated. This is very frustrating. But then if you take it as insult or temper problem or whether that's your judgment, and I don't want, you can think whatever you want to think. Go ahead and do it, no problem. But please turn off your mic unless if you have a question. I want to continue and finish. I'm already behind.
I have a question.
Yes, go ahead.
On the left side isn't that you're calculating the current on the left side, right?
No,
So
No,
why,
okay, yeah, let me clarify this one. I'm gonna write it. You're right. I mean, this is not B. Yeah, on the left side, you're right. Okay, you have two options to find V1. Again, no class participation. You can just, if you want, you have other things to do, other chores to do, you can go ahead and do it. I'm not gonna go do even roll calling today. Okay, let's say V1, you have two options. Either voltage division, which is 10 ohm divided by 10 plus 20 multiplied by 50. Okay, so this is voltage division. The voltage V1 across is 10 ohm divided by 10 plus 20 times 15, or you can find the current, which is 15 divided by 10 plus 20 amp. This is current, volt divided by summation. And then V1 is equal to 10 times the current, which is 15 over 10 plus 20. Okay, so you find this voltage V1, you put it aside, let's calculate. So it's equal to 150 divided by 30. By the way, again, I want to mention that, yes, both mechanical engineering and electrical engineering, they offer this class in a spring. For mechanical engineering, you can take it anytime. For electrical engineering, if you need it as a prerequisite, it should be okay. You're not going to be behind. And other faculty, other instructors are teaching the class, and they may have a different style. Most probably, it's going to be face-to-face, most probably. But they do offer in also both mechanical and electrical, they both offer this class in spring. And you are, I think, if you have problem with this style of teaching, you're much better off if you take it with somebody else. That's why we have different faculty, different styles. That way, you can match your way of learning course material with the teacher. This is my style. Okay, so this is 1015 and V1 is equal to 5 volts. You put it aside. Now you go and kill the other sources. So we have two independent sources. We kill the first source, and now you kill the other sources. The only thing is because of the syllabus rule, I have to take roll calling. I mean, they told me that from the university, chair, whatever we put on the syllabus, we should comply. So I comply with I take not roll calling for the class once in a while, not every time. Okay, now case 2. Keep 2 amp, kill 15 volts. So if you kill voltage source, it becomes a short circuit. So you have a short circuit here, 20, 30, and 2 amp. This is 20, and this is 10. You put the voltage back, you call it V2, because this is for case 2. So we erase case 1, and now it's for case 2. Okay, this is a current source. It's 2 amp. A 2 amp is arriving at this node. Portion of 2 amp goes this way, the other portion goes this way. This is covered in chapter 2. 2 amp, you have 2 parallel branches. I want this current. I want this current. Let's call it I0 or I2. I2, current division law, we have 2 amp and 2 parallel, is equal to 20 ohm divided by 10 plus 20 ohm, current division law. We had exam question, and we had this completely covered in chapter 2. Is the current division law multiplied by 2 amp. So it's equal to 40 divided by 30. It's equal to 4 divided by 3 amp. This is I2, going this way. However, we want V2. V2 is equal, the current goes opposite passive sign, minus 4/3 times 10 ohm. So it's equal to minus 40 divided by 3 volts. Any question?
Yeah, Professor.
Go ahead.
For current division, you only had to combine 10 and 20 in parallel, and that's it?
Yeah, because 2 amp, this current source, remember 2 amp, nothing stops 2 amp. This 2 amp goes directly to the node. There is no change in 2 amp. So 2 amp, this is the same as saying 2 amp. This is this node, 20 and 10. It's the same thing. Remember, any current source in series with anything, the current doesn't change.
Okay, so you're completely 30 doesn't matter in order to get this equation?
No, no.
Thank you.
Notice that any element in series with current source, in a way, it's ineffective. It doesn't affect on anything. And this is one trick that they play again, EIT. I'm also preparing many of you in case if you want to take EIT exam. Many of these questions appears in EIT question. Sometimes they treat you this way. Let's say I put 4 amp here, and then put a bunch of resistors along the way, 2 ohm, 6 ohm, 5. As long as the current keeps moving in series and nothing is branched, and as long as current doesn't branch off, the current remains the same. And current brings all the information. So once you have the current value, you don't need any more information. It's just 4 amp going all the way. So this 2 amp keeps going. It passes through 30 ohm, still 2 amp. So this 30 ohm doesn't play anymore because it's in series with the current source. Any other question?
So for current division, it has to be parallel, right? And for
Yes.
division, it has to be series. That's
Yes.
Okay, thank you.
And current division, remember for voltage division, we use the same resistance. For current division, notice we have 20 and 10, but I need this current, right? It's the other resistance. It's 20 divided by 10. Remember for voltage division, if I want to know the voltage here, I use this resistance. But for current division, it's the other resistance, 20 divided by 10 plus 20 times 2 amp. And then this current coming from 2 amp goes along non-passive sign. Because remember, the original question, you are not allowed to change the polarity. It's minus plus here. Because it's non-passive sign, you have to put minus sign. Any questions so far? Okay. Now, let's go back to original problem. What was the question original problem? What's V? We divided into 2 cases, V1 plus V2. So V, when both sources acting together, it's equal to 5 volts minus 40 divided by 30, and then you simplify. That's superposition. I'll do another problem from textbook, but do you have any question before I do another problem from textbook?
Homework problem.
Which homework problem? I'm talking about superposition. Do you have any question about superposition?
Yeah, Professor.
Yeah.
For voltage, did you use voltage division on that last step, or was it simple Ohm's law to find voltage
Division. I use voltage division. Let me put the circuit back here. You're talking about case 1, right?
Where a negative 40 over 3 volts? Is that case 1?
Oh, yeah, that's Ohm's law. That's Ohm's law. Yeah.
Ohm's
Because,
law. Okay,
because you get current, right? You get a current, and then current times voltage is equal to voltage. Current times Ohm is equal to voltage. Yes, Ohm's law. Okay, let's do another problem. Again, I'll do it myself. And if you have any question or class participation, just those of you who are listening, if you have any question, please stop me at any point. Even if 5 people are listening, that's fine. They can just ask question anytime. Okay, actually I could erase it here. This is the example from the book. So I give you enough time to copy if you want. And it said, Good example of superposition. Notice the good thing about superposition is you don't have to simplify anything. You can start fresh. This is one of the homework problems from textbook. I mean, not homework problem. Sorry, one of the practice problem from textbook. Okay, here this is given us 2 milliamp. Again, if you have any question, please open your mic and ask question at any time. 2 ohm, 1 kilo ohm, 6 kilo ohm, 3 kilo ohm, and 8 milliamp. Okay, the question here is find V0. Actually, if you use nodal mesh, you can use nodal mesh here. You can practice on your own and you apply either nodal or mesh. But here I want to use superposition. By the way, in the exam, if I ask you to use superposition, you must show superposition method. Because, for example, if you use nodal here and get the correct answer, you don't get any point. You have to use superposition. Okay, we have 3 independent sources. 1, 2, 3. Keep one source at a time. So you have 3 cases. If I can squeeze 3 cases here, it's much better so you can see simultaneously. So I have 3 cases. Case 1, which one is acting? 8 milliamp is acting. And the other 2 are dead. So redraw the circuit. For superposition, each case you have to redraw the circuit. And if you have any question about what is left in the circuit, please let me know. That's what can I do? I just keep telling you, please let me know. So you have 3K. Okay, voltage source is not acting, so it's dead. Dead for voltage source is short circuit. This current source 2 milliamp is dead, open. 6K, 2K, 1K. And then the voltage from here to here, it's V0, but for case number 1. Do you have any question about this circuit?
So you didn't draw the top because it doesn't have anything else running through but the independent source?
Yeah, because you keep only 8 milliamp, right? So 8 milliamp is acting, voltage source is off, it's a short circuit. Anytime voltage source, you turn off voltage source means voltage is 0. Current
Yeah,
is
I get
passing.
that, but
Yeah.
I'm saying like if
And
there
2
were,
milliamp
like,
is also open, yeah.
I'm saying if there were like a resistor or anything up top, you would keep it, right? You would just open it.
Yes, 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 yes,
So does this mean we're going to have 3 cases?
yes. Then we have case 2. For case 2, okay, 12 volt is acting. Keep all the passive elements. Just kill the source. So in this case, the current source 8 milliamp is open. So you're left with 3K. Voltage source is acting. Is 6K. 2K. And 1K. This is, oh, the current source is also open. So only voltage source is acting, 12 volt. So you have to measure, again, the same question, but case 2. Any question for the circuit here? Remember, in the exam, if it's a say question, even if you draw the circuit, even if you do the wrong calculation, you still get some point. So at least try to fully understand how to draw the circuit when you kill the sources. Okay, you go to case 3. For case 3, okay, you keep 2 milliamp, kill 8 milliamp open, voltage source short. So you have 3K, voltage source short, 6K. This one is the trickiest when you do the circuit analysis, and 1K. Notice that superposition is not like a shortcut because you have to do 3 circuit analysis problems instead of 1. Nodal is one shot, like one equation, one set of equations or 2 equations. Mesh is just one procedure. But superposition, you have to, but the reason you need to understand or to learn superposition is in future, especially when you have a combination of AC/DC, you have to do it. So that's why you practice here in order to use it later. So this is voltage and the current source is acting. This is current source. 2 milliamp. So, oh, sorry. My drawing is wrong. Okay, this is the correct one. Sorry, my drawing. Let me redraw. Let me redraw this part. Okay. Let's say we have current source open. We have 3K. Then this is a voltage. No, actually it was correct. This is a voltage source. This is 3K. The voltage source is short. You have 6K. No, my drawing was actually correct. 2K and 1K. Okay. And now you have a current source here. Okay, this is 2 milliamp. Okay. Now you have 3 circuit analysis problem. You have to find VO1, VO2, VO3 with superposition. But the only advantage is for each case, you only have 1 voltage source left. So you can use voltage division, current division.
Professor?
Yeah, go ahead.
I think the 2 amp goes into the 3 ohm, right? Not the 6 ohm. The branch it branches into the 3 ohm, not the 6 ohm. The current, the 2 amp current.
Oh, 3K. Yeah. It's the same because they are short circuits. So, yeah. But it's okay. Yeah. But no. But let me make it so to avoid confusion. You're right, because here, let me just at least let's make the drawing correct. But this node is the same node, but it's okay. Okay. So let's start with this one, V1. V1 is the voltage across 1 kilo ohm, and I have 8 milliamp. Okay, what I can do is there are sometimes, I can combine, in this case, notice that this problem is given, it's one of the early problems in circuits. So they assume that after chapter 2, assume that they should easily calculate. But sometimes you don't know how to start. Anytime you have a single source, it's better that you think about voltage division, current division. Actually, you can still use nodal and mesh to do each one of them. You can still use other circuit methods. But what I'm going to do at this point, I'm going to find total. This is the total voltage from here to here, plus or minus. I'm going to call it V. Okay. What is the voltage? From the end, you can combine. You have 3. Don't worry about VO1. Don't worry about VO1. Find this total voltage. Notice that 2K in series with 1K, in parallel with 6K, in parallel with 3K. So 3K and 6K in parallel, it's 6 times 3 divided by 6 plus 3. Okay. So it's equal to 18 divided by 9, it's equal to 2 ohm. Then you have 2 plus 1K, which is 3K, in parallel with this combination, which is 2K. It's 6 divided by 5K. Now, what is this V? V is equal to 8 milliamp, Ohm's law, 8 milliamp times this total resistance, which is 6 over 5K. Milli cancels kilo. So you get 48 divided by 5 volts. This is V, this voltage V. Okay, this voltage V is the same as this voltage because these are parallel. So this is also V. You have V here and two resistors in series. Use voltage division. VO1 is equal to 1K divided by 2K plus 1K multiplied by V. This is V. And then you find U. Do you have any
Wait, can you
question?
show that
it.
step over?
Yeah. Okay, first, let's go slow this one. I have 8 milliamp here. 8 milliamp sees the total resistance of what? Remember, we had this before. Go from the end and combine all the resistors. 1K in series with 2K. 6 and 3 in parallel. 6 and 3 in parallel is equal to 2. 1 and 2 in series is 3. This combination in parallel with this combination. So you find the total resistance. This is a total resistance. Total current times total resistance is equal to the total voltage. This is the total voltage from here to here. This is the total voltage. This total voltage, you keep going, moving this V because it's parallel. So this total voltage, you can move it all the way up to here. Like you can move it to total voltage plus or minus V. Then you have 2K and 1K. Once you find total voltage, you can move it all the way up to here. This is V. Then you have 2K and 1K. So what is this voltage VO1? It's 1K divided by 1 plus 2 multiplied by V. That's voltage division.
And
Professor,
V was the 48 divided by 5, right?
Yes.
Okay.
So it's equal to 1K divided by 3. So it's 1/3 multiplied by 48 divided by 5. So it's 16 divided by 5. Yeah, some question?
yeah, I was a little bit, so V01, was that the voltage we found
Because remember, they ask you to find
from
V
the
naught.
equivalent
Yeah, from V naught.
resistance?
Yes. You have to find V naught.
So is it, are they flipped around? I'm sorry for cutting you off.
No, this is V naught across 1 kilo ohm. So when you go to each case, you're not allowed to change the location of V naught. So this is V naught for case 1, V naught for case 2, V naught for case 3. Okay,
And
here it's a voltage across 1 kilo ohm. So first, I'll do it in 2 steps. First, I find total voltage, V, by combining everything. I find total voltage. That's total voltage V. The total voltage across the current source. I find it first. Then I move that voltage because everything is parallel. Notice that if you have parallel elements, if I find voltage here, the voltage here is the same, the voltage here is the same, the voltage here is the same, across parallel. Across parallel, you have the same voltage, all the way to as many elements you can pass, still keep the parallel, because as long as they're in parallel, they keep the same voltage. So I move this V from here all the way to here, when I highlight, all the way to here. Okay, when I put plus or minus V here, what is to the right of V? 2 kilo ohm and 1 kilo ohm in series, right? Then I use voltage division because I want V naught 1. V naught 1 is the voltage across 1 kilo ohm. What is to the left? Total voltage V. What is to the right of V? 2K and 1K in series. So the question is, what's the voltage across 1K? I'm using voltage division. 1K divided by 1 plus 2 multiplied by V.
okay, so
That's-
if
that's-
I understood, I think I understood you correctly. You're saying, yeah, you're saying that V01 is what we're supposed to find. And
Yes.
okay, then I understood everything else.
Yeah. You have to find it. Because in superposition, you have to find the question from the beginning. Remember in nodal mesh, we forget about the question until the end? In superposition, you have to use question from the beginning. Any question, because this is also a practice of your previous, like whatever they call it, I don't know, single source analysis, voltage division, current division. Eventually, and also the fact that superposition for some people is not a shortcut. Because for superposition, you have to do circuit analysis 3 times, 4 times, 5 times because of the independent sources. But again, I want to emphasize, you have to know superposition in future when you have multiple shape sources, when the sources are not consistent. Notice until chapter 8, we only cover DC sources. But after chapter 8, we have different shape voltages. We have different forms. So in that case, you have to use superposition.
Professor,
Yes, go ahead.
is this is that because the current is not going to be the same since 2 and 1K are now in series?
Yes. No, they are in series, the current is the same. Yeah, because remember, this end doesn't go anywhere. This end is open.
Okay, I'm okay. Thank you.
Notice that in original circuit, okay, when you ask this question, remember, this is after killing the current source circuit. Original circuit, notice that 2K and 1K, they carry different currents. Because this node, you have essential node here. So the current through 2K and 1K, they are not in series in original. But if I remove the current source, then they become series. If I remove the current source, 2K and 1K, they become series. Okay, let me keep this answer someplace. So I have 16 over 5 volt. This is V01, because I want to delete this one. So we go to case 2. Case 2, we have to find V02. And we have a single source. So I'm going to think about voltage division, current division, if it's possible. I can do the same thing, and I can use current division. There are several options. You can use any method. You can even go back and use nodal here. It doesn't matter. But I'm going to do it this way. Go to the location of 12 volt. Go to this location and find the total resistance. Suppose you're standing here, looking into the circuit. Find total resistance. First of all, this end is open. So you have 2K plus 1K in series, 3K. This 3K is in parallel with 6K. 2K. Then this 2K is in series with 3K. Okay, let's do it one by one. 2 and 1 in series, you get 3 and 6. Combination in parallel, so you get minus plus 12 volts. 3 and 6 in parallel, 2K and 3K. Okay, so suppose you're standing here. What do you see? 3K and 2K in series, 6K. Okay. Now, this was actually a challenging problem, but it was presented in early part of your textbook. So I have 6K total resistance, 6K seen by 12 volts. So what's the total current? 12 volts divided by 6K. 2, because of K here, milliamp. 12 volt divided by 6K.
Professor, you have 2K plus 3K equals 6. Shouldn't that be 5K?
Oh, sorry. Right, thank you, sorry. You're right. Actually, 6 was better, but you're right. Thank you.
I'm still trying to see where you got the 5K from. I see where you did
Okay.
the 3K and the 18 over.
Okay, let's go step by step. 2 and 1 in series. Do you see that? Because this end is open. Okay, 3K and 6K in parallel. Do you see that?
Yes.
Okay, so redraw the circuit. After you combine 3 and 6, you get what? 2K, right? And 3K. Okay, suppose you're standing here and looking into the circuit, because this is the resistance seen by the source. What do you see? 2K in series with 3K. Remember, finding equivalent resistance is terminal based. So if you're standing here, it's like move it around, like orientation, plus, minus. What you have? You have 3K and you have 2K because you're looking into the circuit around this terminal. So you see 2K and 3K in series. So it's
2K
and 3K. So it's in series, so it's 3 plus 2.
I'm still kind of confused.
This is 2K. This is 3K. What do you see? What's the total resistance?
I see it's 5, but
Okay, 5K.
yeah, but from the drawing, because I see you did voltage division from 6 and 3K because they're parallel and they gives you 18/9.
I didn't use voltage division yet. I'm just saying I'm finding, okay, if you, by drawing 2 plus 1 is 3, 3 in parallel with 6 is 2, it's 2K. So what is after this point?
Oh,
What
and then
is-
you use it as the same, it's in the same
It's 2K,
circuit.
yeah.
Okay.
Yeah.
I got it.
It's the same circuit. Yeah. And then, okay, after that, so this is a circuit. So what's the total current coming from the source? It's 12 volt divided by this total 5K. So it's equal to I is equal to 2 points. I is equal to 2.4 milliamp, milli because you are K. Okay. I haven't answered the question yet. Now let's go back to the circuit and show this current. This is the current, right? This is the current because this is the current coming from the source. This is the current. Go back and show it in the circuit. Okay. This current is arriving at this node. What do you see? What do you see in front of this node? 2 and 1 in series and 6K. Okay, and there is a current I arriving at the node. 6K and 3K. Find this current. Call it I2. Current division. It's equal to 6K divided by 6 plus 3 times I times 2.4 milliamp. So you find total current. Then you see 3K in parallel with 6K. You want this current because you want to find V01. I mean V02. So you must find, oh, sorry, 1K, sorry. What did I say? 3K, 1K, sorry. This is 2K. Let me redraw. Actually 3K, yeah, because I added, you understand, I mean, I added 2K plus 1 is 3K. So I'm going to add first. So this 3K is correct. This 3K is correct. I wanted to separate, but then I said, this is easy. Current is arriving here. 2 plus 1 is 3. 6 here. I want this current. I want this current. Okay, this is my I2. And I have I2. I use current division. 6 divided by 6 plus 3 times 2.4 milliamp. This is my I2. Okay, if I have I2, what is VO2? Ohm's law. 1K. So after finding this one, from here, VO2 is equal to 1K times I2. So VO2 is equal to 1K times 6 divided, it's 6 divided by 9, multiplied by 2.4 milliamp. Milli cancels kilo, so it's equal, and 6 divided by 9 is it's 2, so it's equal to divided by 3, so it's equal to 1.6 volts.
And it's 1K instead of 3K. Why?
No, because the current, like you have two branches. You have to consider the whole resistance over the branch when you write your current. You have 6K here, and then 2 plus 1 is 3K. Because this whole branch is taking I2, not just 1K. The whole branch is taking I2. So you have 2 plus 1 is 3K and 6K in parallel. So what is I2? 3 using current division is 6 divided by 6 plus 3.
No, sorry, I was talking about V not 2.
Sorry?
V not 2.
Yeah, V naught 2. V naught 2, then after you find I2, you have to find V naught 2 because the question, you have to find this voltage. V naught 2 is equal to I2 times 1K. First you find I2, and then current times 1K is equal to the voltage. And this is V naught 2. So you put V naught 2 on the side. V naught 2 equal to 1.6 volts. Any question about this? Okay, so let's do case number 3. This is actually took more time because of actually I'm doing more circuit with this one rather than showing superposition. Superposition is basically one source at a time. The rest is just a circuit analysis. Okay, so let's go to case number 3. But it's maybe at this point, if you're not forced to use superposition, you appreciate nodal mesh. You can see nodal mesh can take you to the final answer very quickly. You can try nodal mesh on your own. But again, they wanted you to do superposition as a preparation for future AC analysis. So, okay, let's go to case number 3. This is case number 3. So we keep the current, and this is the current, 2 milliamp. And because notice that this is 2K. This is 2K. 6 and 3 are in parallel. Combine it. Okay, 2K here. This is 2K, 6 and 3, and then this end is 1K. This should be easy, easier than the other previous 2 cases. Okay, I'll show you the pathway. A 2 amp is arriving at this node. One branch goes this way, one branch goes this way. This one, we call it I3, current division. So I3, 2 amp arriving at this node. Notice that 2K and 1K, they are in series. You have to put yourself in the place of the current source and looking into the circuit. When you are standing across here, 1 and 2 is in series. So we have a current going through 3 kilo ohm combination and 2 kilo ohm on this side. So what is I3? I3 is equal to 2 kilo divided by 2 plus 1 plus 2 kilo. 2 plus 1 plus, this combination is 3 kilo, multiplied by 2 milliamp. So it's equal to 4 milli divided by 3 plus 2 is 5. 4 milliamp multiplied by, let me write it better here, 2K divided by 2 divided by 5 multiplied by 2 milliamp. So it's equal to 4 over 5 milliamp. Okay. Go back to original picture. You want this voltage. This is VO3. Again, you have the current I3, you have ohm, so VO3 is equal to 1 kilo ohm because you just want this voltage multiplied by I3. So it's equal to 1 kilo ohm multiplied by 5 milliamp. Again, milli cancels, so it's equal to 4 over 5 volts. This one was the easiest one. Again, if you use circuit number 3, 3 and 6 in parallel, 2. 1K on this side, 2K here. And then we have a total current 2 milliamp. Total current arriving at this node divided into 2 parts, this part and this part. This part, you have a combination of 3 kilo ohm. So current division law, you want this current, is the other resistance 2 divided by 2 plus 3 multiplied by 2 milliamp. You simplify, multiply by 1 kilo ohm, you get voltage. Any question here?
Quick question, Professor.
Yeah.
For I3, can you explain how you have the parentheses 2 plus 1 again?
Because, okay, if you're standing here, let me draw this circuit this way, because you remember, circuit style sometimes is confusing, but you can always make your own drawing and make it a little bit easier.
I think I see it. Is it because it's
Yeah.
in series?
Yeah, because 2K, you can, because these two, they are back to back now. If you're
Okay.
if you're standing here, when you look, these two are in back to back, it's like 3K.
Okay, got it. Thank you.
Yeah. Okay, so you have V01, V02, V03. V03 is equal to 4/5 volts. Now, you go back. This was a very detailed problem, actually, but it was good, actually, because of the superposition played very small role. Just keep one source at a time. The rest was just repeating circuit analysis, voltage division. Okay, here is superposition. The end of superposition. Okay, now let's have the complete circuit. All 3 sources acting together. What is V0? So rather than considering all of them acting together, since I divided into 3 parts, and I found the answer for 3 parts, exactly the same as solving differential equation, when you have several forcing functions. Now V output 1 is equal to V1, V output 2, or V out and plus V output 3, V naught 1, 2, 3. So it's equal to 16.5 is, because let me put the same number so you don't get confused. 16/5 volts. And please double check my calculations sometimes. I did it. Volts, you don't have to put the unit, but just to show you. And then 4/5 volts. So this is the voltage, the output if 3 sources acting together.
5.6 volts.
Sorry?
5.6 volts.
5.6 volts. Okay. That's it. That's superposition. There's nothing else to say about superposition. By the way, one thing just before I finish the lecture. Okay. This is very important because they do play this trick, again, as I said later. Let's say I have a dependent source here, for example. I'm not going to repeat the problem, but let's say dependent source. You cannot, let me write it here. If I have a dependent source, let me just give you a simple example because it takes only a few seconds. I mean, just use this example, it doesn't matter. Because I'm not going to do the calculation. Dependent source is causing problem with superposition. Why? Because you cannot kill the dependent source. Let's say that this dependent source, the value of the dependent source, it just takes a few minutes. Let's say it's equal to 2I. And this is I, for example. Okay, it's a dependent source. You only have 2 cases here. Case 1, you keep 8 milliamp. 3 kilo. You have to keep the dependent source. You cannot kill the dependent source. And you remove so this is plus or minus V01. No change here, except that you cannot kill dependent source. You have to keep it. You remove the current source, you keep this current source. However, when you write the value of the dependent source, what is 2? You have to put 2I1. And you have to call this one I1 because this is not total I. It's I for case 1 only. So you only have two cases. You cannot kill dependent sources. You have to keep it and readjust. So this is case 1. For case 2, you kill 8 milliamps, so you get 3K. You still keep the dependent source. You still keep the dependent source, 6K, 1K, plus or minus VO2, 6K, 2K, 3K, and then you have from 3K. You keep the current source here, 2 milliamp, but you still, remember, this was, you call it I2, and this is 2I2. You have to keep the dependent source. So that's why dependent source makes the problem a little bit messier if you want to use superposition. That's why, unless if you have to use superposition, especially with dependent sources, don't use superposition. It makes it too long and messy, especially when you have a large circuit. Use superposition as your last resort when you have different type sources, AC, DC, unless if you have to, or unless if the problem is specifically asking you to use superposition. If you're on your own and you're thinking about method to solve circuit problem, try to, in general, especially when you have large circuit, like in this case, when we have multiple loops, multiple sources, don't use superposition. It makes the problem a little bit longer. It's much long. I mean, in general, it's not like a shortcut, like a nodal or mesh. So this is something I want to mention, that with the dependent source, you cannot kill the dependent source. If you have any question, please ask. Otherwise, have a good day. I just wanted to mention this.
Is there any way you can?
Problems?
Sorry? If I ask a superposition question in the exam, I'm not going to give you with a dependent source. As I said, it just makes the problem way too long.
Understood.
But eventually, when you get into circuit analysis, especially if you're EES students and in future you're using many times AC/DC, I probably give you one homework problem just to practice. But in the exam, again, you need to practice it and keep it someplace in case if you need it and you have to use it. And here I have to show you always.
With the nodal on this equation, or no?
You can use nodal here. Yeah, nodal is perfect. Actually, nodal is perfect here. Or even nodal is the best for this. Nodal is the best for this.
I'm saying, can you include it in like an answer key in our email, or?
For this one, nodal. I already did the nodal. Just you can. This is nodal V1. This is node. Actually, we had a problem similar to this one in my answer key. I think homework problem number 4. Homework number 4, I think you had similar to this one with a dependent source using nodal and mesh.
We didn't get the answers for 5 either in homework number 5.
For homework number 5, after collecting today, operational amplifier. Today is the due date for homework number 5.
Oh,
I did send number.
I thought it was on Monday at 11.
No, number 4. Today I'm collecting number.
Tuesdays,
yeah,
not Mondays.
No, Monday, Tuesday. And maybe I put it's always the day of the lecture.
Okay, I always submit it Monday.
You can resubmit if you want.
Okay, thank you.
Okay, any question?
Professor?
Yes.
Just I had a question just because a quick question on case 1.
Go ahead.
You know, how come the V wasn't the same thing as V naught 1? You know how you use voltage division to solve for V naught 1?
Are you talking about the dependent source case?
On the case, oh, I'm sorry. No, it was the first problem.
Okay, the first problem when I had, okay, V naught 1, the first problem I had.
You pretty much had it was 3 resistors, and you would use voltage division to solve for V naught 1.
No, I use voltage. I use the. Oh, I can also use voltage division if that's your question. Yes, you can do that. Are you asking if you can use voltage division here for V naught 1?
I mean, no, I was asking for the other case, but I right there is important too. I guess I asked the question that's too early in the lecture. It doesn't make sense now to ask that.
If you are specific, okay, let me.
Can you
see.
explain that then? What you just mentioned? That would be fair enough. I'd get it fair.
Okay, for voltage division, using voltage division, okay. So this is for case 2 or case 1, which one?
Case 1.
Okay, for case 1. For case 1, I didn't use voltage division, I used current division. For case 1, are you talking about this problem or the simple problem I gave at the beginning?
The simple problem you gave at the
Okay,
beginning.
at the beginning, okay, let me do that. This is the problem I had. I had a voltage source. That problem was from handout. So I had a voltage source here, 15 volts, 10 ohm,
Oh,
20 ohm, and 30. This was problem number 1. 2 amp. Okay, so for this one, case 1, I had 15 volts, 10 ohm, 20 ohm. This part, because of the current source is open, it's hanging, so I don't even have to show it.
okay. I get that.
Yeah, the question here is find V0. We call it V01. Okay, in order to find V01, I use voltage division. It's 10 divided by 10 plus 20 times the input source. Because it's a series circuit. So V01 is equal to 10 ohm divided by 10 plus 20 times 15.
So if you created an open circuit, like if you just extended the top and bottom lines over.
Here? Yeah, that's open circuit, yeah.
So if that was called the V01.
Yeah.
Pretty much. Okay, that's where I was, the question was, if that was called V01,
If
that's
it's
why it wouldn't be the
V01,
same voltage. Okay,
no,
because
no,
it's in
because
series.
V01 is equal to 20. If you call this one V01, for example, because question given by the problem gives you this question. If they ask you to find, let's say, this question, for example, then this V01 was the voltage across 20. Then you had V01 in this case. In this case, V01 would be 20 divided by 10 plus 20 times 15. So
15 divided 20.
Yeah, because in this case, V01 is 20 voltage across 20 divided by 20 plus 10 times 15 volts. If voltage across here is in the question, is 10 divided by 10. Voltage division is like this. Plus or minus V input, R1, R2. Any voltage, let's say V2, is equal to R2 over R1 plus R2 times V input.
Okay, yeah, that helps out because that same thing, the same issue that we're talking about happens in a lot of other problems. So that helped me with that confusion.
Yeah, I mean, if you want voltage across R1, then it's R1 over R1 plus R2. Now in current division, it's the opposite. Like in current division, it's parallel. So when you have current division parallel, let's say, I have another class, but it's okay. Let's say you have R1, R2, I. Then if you want I2, it's the other resistance. R1 over R1 plus R2 times R. In voltage division, is the same resistance. R2 over R1 plus R1 times voltage.
Thank you, Professor.
Okay, have a good day. I have to go to another class.
Thank you.